नमस्कार, आदाब, सत श्री अकाल। कैसे हो? बढ़िया। आई होप you all are doing well. So today we are going to learn about few things. The very first thing is we are going to learn about the charging and discharging process of an atom, and then we are going to learn about motion of a charged particle in uniform electric field. And after this, if time allows, we will study about the area vector and electric flux. Okay. So the motto of the class is charging and discharging of atom. Then we are going to learn about motion of charged particle. After this, we are going to learn about the area vector, and electric flux. Electric flux. So let's begin with the charging and discharging process of an atom. Charging and discharging process of an atom. What does it indicate? इसका मतलब क्या होता है? इसका मतलब होता है बेटा कि जब भी आपका एटम होता है तो आप एटम को चार्ज कर सकते हो और डिस्चार्ज कर सकते हो। बट एटम की चार्जिंग एंड डिस्चार्जिंग की प्रोसेस होती कैसे है? हाउ द चार्जिंग एंड डिस्चार्जिंग अकर्स? तो वी शुड अंडरस्टैंड वन थिंग, दैट एटम इज मेड अप ऑफ अ न्यूक्लियस एंड सराउंडेड बाय सम इलेक्ट्रॉन्स। कुछ न्यूक्लियस से मिलकर बना है एंड सराउंडेड बाय इलेक्ट्रॉन्स। Now we can say that the number of protons and number of electrons are equal. Number of protons and number of electrons are equal. It means it's an neutral atom. It's an neutral atom. A neutral atom. Then what does this charging and discharging process means? Charging and discharging means whenever I remove some of the electrons from the orbit of this atom, whenever I remove some electrons from orbit of these atoms, then there will be some deficiency of electrons in this atom. There will be some deficiency of electrons in this atom. And the deficiency is being shown by these holes. And this holes means what? It is a deficiency of electrons. It means it is lacking some electrons and it is bearing some positive charge. It is bearing some positive charge of 2 electrons. Now, if I consider another case, let's suppose there were 4 electrons in the orbit, then it was a neutral atom. And if it was a neutral atom, then if I have supplied some more electrons to this atom, Now somewhere I have arranged some electrons and I have supplied this atom some more electrons. Then what will happen, beta? What will happen? Something will happen like in this scenario, the atom is going to have excess of electrons. How many electrons are in excess? 2 electrons are in excess. It means it shows that the atom is having 2 more electrons. Then the charge in this atom is minus 2 electron. The charge in this atom is minus 2 electron. Now, do you think about that the protons helps in the charging and discharging process? Then no. The protons are having no roles in charging and discharging process. The protons are held by a strong nuclear force, and nuclear forces are the strongest nuclear forces among the 4 fundamental forces. Nuclear forces are the strongest force among the 4 fundamental forces. It means we cannot remove some protons, or neither we can add some more protons to this atom. The entire process is being done by exchanging of electrons. What is happening? There is an exchange of electrons. Somehow we have removed some electrons and somehow we have added some more electrons. If we have removed some electrons, then there was some deficiency of electrons and it creates some positive charge to the atom. And if we have added some more electrons to the neutral atom, then it has excess of electrons and it will be having some negative charge. I hope this process is clear. It means we can say that discharging, and discharging of 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 an atom occurs due to exchange of electrons. This entire process occurs due to the exchange of electrons. Neither the protons are involving in this process nor something else is involving. Only there is some exchange of electrons occurring. Now, let's suppose I am asking you one question. There were two different atoms. The mass of A and mass of B is equal. And let's suppose I have given this A atom some additional charge. It was earlier a neutral atom. And I have supplied some positive charge to this atom. And let's suppose I have supplied some negative charge to this atom. Plus Q and minus Q I have added to both of these atoms. Earlier, both of the atoms were having the same mass. Now, if I ask you one question, whether the mass of A will be greater than mass of B, or the mass of A will be equal to mass of B, or the mass of B will be greater than mass of A. After this process, when I have added some charges to this atom, I have added plus Q to this atom and minus Q to this B atom. Now what will happen? What will be the change in the mass of these atoms? Whether the mass of A will be greater than mass of B, or mass of A will remain same to the mass of B, and mass of B will be higher than mass of A. So we have understood this process, that whether I am supplying some charges to the atom, if I have supplied positive Q charge to this atom, it means it shows that there were some electrons in the orbit, and I have removed some electrons from the orbit of this atom. And if I have supplied minus Q charge to this atom, it shows that I have added some electron to the orbit of this atom. And if you think consciously, then you will see that if I remove this electron, then there must be some loss of mass. There is some mass of the electron, yes, 9.1 into 10 raised to minus 31 kg. And if I have added some electron, then there must be some addition of mass. How much addition? Mass. It is 9.1 into 10 raised to minus 31 kg. So by this process, we have seen that the mass of B is increasing. But mass of A is decreasing. So by this process, we are clear that the mass of A is higher than the mass of B is higher than the mass of A. It is the correct option. So this is how the charging and discharging process occurs. There is no role of proton in it. I have added positive Q. It doesn't mean that I have added some protons to it. No. Protons we cannot add because they are bounded by the nuclear forces, and nuclear forces are the strongest force. And strongest force, by having the strongest nature in the universal fundamental forces, we are not able to separate them, or we are not able to give some additional protons to it. Nice. Good. I hope it is clear. Then again, the charging and discharging process is clear. Now we should move forward for the motion of a charged particle in a uniform electric field. Good. Let's suppose I have given some uniform electric field. E. It's a vector quantity, yeah. And I have supplied one positive charge. Let's suppose I have given some Q charge, and I have thrown this Q charge to some initial velocity of V, or initial velocity of V. Now what will happen? This electric field will imply some force to this charge, and it will repel this charge. Once it starts repelling this charge, then the velocity of this charge, the speed of this charge will be increasing. Yeah, obviously it will be increased, because if electric field is applying some forces to the charge, positive charge, and it is opposing the, it is opposing the motion of this charge, sorry, it is supporting the motion of charge, then the velocity of this electron will be, this charge will be increasing. Once the velocity is increasing, it means it's an accelerated motion. It's an accelerated motion. Now let's consider one another case where I am having some electric field. Again, the same electric field, the same magnitude, and it's an uniform electric field. And I have put one negative minus q charge of the same magnitude, which was earlier I have considered positive q charge. And if I have given minus q charge and provided some initial velocity v, if I have thrown this charge in a uniform electric field and my charge is of magnitude negative, I have thrown this charge and it will start, this electric field will start repelling this charge. And what will happen? What will happen? It will experience and opposing force, and the velocity will soon reduce. Once the velocity is getting reduced by the opposing force, opposing nature of the electric field, it will start repelling this charge. Then what will happen? It will reduce the velocity, and the reduction of velocity is known as retardation, or we can say the reduction of velocity is known as negative of the acceleration. Is known as negative of acceleration, or we can say it's a retardation. Good. I hope it is clear. Both of these charges were in a straight line. How they are behaving? They were in a straight line motion. Straight line motion. And if you ask me what is the acceleration, yeah, it's a good question. If let's suppose this motion is occurring in a straight line, then we can apply some Newton's law of motion. Yeah, of course we can apply. It's facing a uniform acceleration. Good. That's another good thing. And if I consider the force on this charge is an electrostatic force. And how is the force? How much is the force? The magnitude of the force is Q into E. And it's accelerated by A acceleration. Then I can equate both of the equations, because it's a Newton force and it's an electrostatic force. Both of the forces are equal. Then the net acceleration will be experienced by this charge will be QE by M. And it will be in the positive direction, or we can say accelerated motion. And at the same time, if I try to find the acceleration of this negative charge, then it's in retardation motion, and the acceleration which comes is the force, the electrostatic force is minus QE, and the Newtonian force is MA. If I equate both of the equations, then I got to know about minus QE by. And this acceleration, this negative sign shows that it's an retardation process. I hope we get a clear idea about the motion of a charged particle in uniform electric field. What is the acceleration comes out? It's QE by M. And if in case of retardation, it comes to a minus QE by M. Yeah, good. Now we should move forward, and we should look about the motion and the equation of the motion. We are not able to know about the equation of the motion. We just got to know about the acceleration of this charged particle. Good. So sir, we should find the acceleration too. We should definitely find the equation of the motion of the charged particle. For this, we should consider another case. Let's suppose what happens if my electric field is in this direction, is in this direction, and it's a uniform electric field. Yeah. And let's suppose I have thrown one charge. Let's suppose I have thrown one positive charge. I have given some initial velocity v. Once I have given it some velocity v, then how it will follow the path? What could be the path of this charge? Sir, I have thrown this positive q charge. Positive q charge. So there must be some motion due to this electric field. Yeah. And there must be some motion due to my I have given some velocity to this charge. So there must be some motion in x direction. And there must be some motion in the y direction. But sir, simultaneously x direction, the motion is occurring in x direction and the motion is occurring in y direction. Then what will happen? Sir, it will follow some path, like it will go somewhere in x direction and somewhere in the y direction. Then it may follow this kind of path. It may follow. I'm not confirmed about this path, but I'm thinking, like, by my general thinking, I'm able to think that it's going into x direction. Another force is in downward direction. Then there may be some net force in this direction, and the path may be kind of this. I can assume like this, but assumption is not correct thing. Assumption, nahi. I don't want any assumption. We want some proof. Okay. Then let's prove something. Let's prove it. So, first of all, give me the solution of my problem. Let's suppose it's a tall building, and I have thrown two balls simultaneously. At the same time, I have thrown two balls. In one ball, I have given some velocity. In one ball, I have given some. Let's suppose this was A, and this is B. I have given some velocity of V. Let's suppose I have given some uniform velocity V. In the x direction, in the horizontal direction, I have provided some velocity V. And at the same time, I have not given any velocity to the B. If I have not given any velocity to B and I have thrown both of these balls, then A will follow this path. Yeah, definitely. It will follow this path, but motion due to gravity, what will happen? It will simultaneously comes down like this. And at the same time, I have put this ball from the top of the building and released it. Once I have released this ball, the horizontal velocity, the velocity in x direction is how much? 0. Because I have not given it. What I have given it is I have put it into a free fall. There is no air resistance I have considered. And if I release this ball B from the top of the building, what will happen, beta? What will happen? It will come under the gravity and be on the ground like this. Yes. But can you tell me the time? How much will be the time taken by the B and by the A? Is there any difference in the time taken by A and time taken by B? Is there any difference? What will happen, beta? What will happen? What will be the time taken by B and time taken by A? Will there be any difference in the time taken by both of the charges, both of the balls? Let's think about it. Sir, you have not given any horizontal velocity to ball B, but you have given some horizontal velocity to A. But the vertical motion of ball A and ball B is same, I suppose. Yes, sir. Because you have given some velocity to the x direction, but not given any velocity to the y direction. The initial velocity to the y direction is 0. The initial velocity to the y direction of A is 0. And both of the balls are falling under the free fall, under the sense of gravity. Yes, sir, that's good thing. If both of the things are coming under the gravity, then the gravity applies on both of the balls at the same time. Same. Then what will happen? What will happen? The balls will come simultaneously at the same time, like this. It will follow the same path. Sometime it will be like this. After some time, it will be at the same position, same position, same position. Because you have not given any vertical velocity to the balls, then they will fall under the gravity. Yes, sir, definitely. Then there will be no disturbance in the vertical motion. If you have seen that I have given one ball horizontal motion and another ball no horizontal velocity, zero horizontal velocity, then it shows the horizontal velocity and the vertical velocity are different things, are different, and 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 they are not disturbing each other. They are not disturbing each other. Yes, sir. It shows that the ball A will follow some path and it will be away from the ground, but the ball B will follow the same path and will be at the ground at the same time whenever the ball comes to the ground. It means the time taken by ball A, time taken by ball A will be time taken by ball B. Yes, sir. Is it so? Yes, sir. So I hope this thing is clear, that it shows that the horizontal motion doesn't affect the vertical motion. Horizontal motion will follow the same thing, whatever distance it will cover, it will cover, and whatever the vertical motion will cover, it will cover. There will be no disturbance in both of the motions. Sir, good. Then, sir, then, then, sir, we have to, we have to, we have to, we have to find the path of this motion. What is the equation of this motion? So let's suppose we are considering the motion in x direction first, x direction first, x direction first. That you have given the velocity x, vx, or horizontal velocity v to this charged particle q. It will follow velocity into time equals to x, the same path. There will be no disturbance in the x direction by the vertical motion or by the electric force. Yes. And can you tell me, I have given the velocity, uniform velocity v. If I have given uniform velocity v, then there will be acceleration 0. Acceleration कितना होगा? It will be 0. Because we have given a uniform velocity. कैसी velocity थी? It's a uniform velocity. Uniform velocity. And at the same time, if I think about the path of the charged particle q in the vertical direction, then sir, in y direction, how it looks? Sir, in y direction the displacement may be s y. I can apply the equation of motion in that, because it's in uniform motion. Yes, it's a uniform motion. Why, sir? Why? So you have find the acceleration in y direction was q by m. It's a uniform acceleration. It comes under the motion of electric field. Yes. Then, sir, you can put the equation of motion. You have seen that I have applied the everything of y direction. That is displacement in y direction, the initial velocity of y direction, the acceleration in the y direction. Because I am considering the x-axis, x direction path and y direction path separately. There are no relation of the motion in x direction and the motion in the y direction. Both of the things are very separate. So let's consider the y displacement in y direction equals to y. So uy, how much is the uy? Uy is the initial velocity in y direction, and the initial velocity was 0. So how much is the acceleration? Sir, acceleration in the y direction will be, sir, qe by m. Arre, we have find it now. F equals to ma, F equals to q into e. I'm finding this direction. Then m a y equals to q e. Then a y equals to q e by QE by, I have put it QE by M. Good. So how much is the motion in the y direction? It's, sir, it is like, sir, QE by M into T square. But sir, we wanted to find the relation between x and v. That then only we can find the relation. Then only we can find the equation of the motion of this charged particle. So there must be some relation in the projectile motion. We have also find the equation of motion, equation of that trajectory. When we were trying to find the equation of that trajectory, we have found it, and we have made some relation in between x direction and some in y direction. Then only we have decided that this is the equation of the trajectory. But sir, we are having only y and we are only x. There must be some relation in x and y. Yes, sir. We are able to see that the time taken by the time taken in the motion is same. Whatever the time it takes in the x direction, it is the same time taken in the y direction. Then only the charged particle can come somewhere on the ground. That's the correct thing. Sir, I can write this t as x upon vx. Yes, definitely. And if I had taken t equals to x upon vx, I can replace this t by this t, and I can put it like this. I can put it like this. So if you are able to see, that y equals to 1 by 2 QE upon m, and it's a t square, it means it's x square upon vx square. I can write it like this also. Y equals to 1 by 2 QE by m x square upon v square. And if you are able to see in this picture, in this equation, then you are able to find that it's 1 by 2 constant, mass is the constant, velocity in horizontal direction is uniform, it means it's also constant, electric field was constant, charge is constant. So it shows the entire thing is a constant, except x and y. If I change the x, then it gives me a relation that whenever you are changing x, then there will be some deflection in y also. Like if your x is here, then your y is here. The motion shows that the particle is at this position. X is here, y is here, then it shows the particle is in here. X is here, y is here, it shows the particle is in this position. It shows the position of your particle actually. There is a relation between x and y. And whenever we get the relation in between x and y, it means it means it means it means whenever I get relation in x and y, it means I can consider it as a constant. Let's suppose a constant is a. Let's suppose a constant. You can write it like this also. And you have seen this kind of equations. This is the equation of what? It is the equation of a projectile motion. It's an equation of projectile motion. Y equals to x square. Exactly, sir. Projectile motion. Now you can say it. Now you can say that the motion, whatever this charge is following under the electric field, it's following the motion of a projectile motion. Or parabolic motion. It's the equation of parabola, na? Equation of parabola. I hope it is clear. I hope it is clear. Good. Now I think the motion of a charged particle is clear. The charging and discharging process of a charged particle is clear. How the charging and discharging occurs. The motion of charged particle is clear. It's a very important concept actually. Now only one thing left is the area vector. Area vector. Area vector and electric flux. Let's try to finish it as early as we can. Electric flux. Good. Area vector क्या? What is area vector? Let's suppose you are having one object. Whatever the perpendicular vector of a surface is known as area vector, or we can say the normal vector to the surface is known as area vector. This is what? This is a perpendicular to the surface like this. This is my surface, and whatever the perpendicular normal vector from this surface, it's called area vector. What is this? It's an area vector. Area vector. But sir, how this area vector has been made? The area vector must be having some direction. It shows it is an unit vector. And the magnitude of area vector. The magnitude of area vector is what? Let's suppose this is my surface. This is length and this is breadth. Or you can say this is length and this is your breadth. So what is the area? The magnitude of the area vector. The magnitude of area vector. So this is unit vector and the magnitude of area vector is length into breadth. For this surface, I am considering its length into breadth. For different surface, it could be some another thing, maybe. But for this area vector, we can say that this may be the area vector. So whatever the normal vector from the surface, it is known as area vector. Perpendicular from the surface is known as area vector. This is. If let's suppose I have changed the surface, I have put the surface like this, then the area vector will be like this. So by changing the geometry of your surface, you are able to find the area vector in different direction, maybe, kind of. So this is known as your area vector. But why we are studying in here? We are studying area vector here just because we wanted to learn about electric flux. There are some correlation in area vector and electric flux. What is electric flux? Electric flux. Beta. Electric flux is nothing but the number of electric field lines passing through some surface normally. What I'm telling you. Let's suppose this is your surface. The number of field lines passing through this surface normally. Maybe kind of this. This is normal or this is normal. No. If you are able to see, it is making some angle. The electric field lines are making some angle. Then it is not an electric flux. Electric flux is the flux which the number of field lines passes through the surface normally. Whatever the field lines passing through the surface normally, then it is only known as electric flux. Or we can understand by this example also. This may be the surface, and let's suppose n number of field lines are passing through this surface. Let's suppose 3 number of electric field lines passing through this surface. Are they passing through this surface normally? Yes, sir. It looks like. So the area vector must be perpendicular and the field lines are passing through this surface normally. It means the electric flux is how much? 3. The number of field lines passing through the surface normally is how much? Is 3 number. So the electric flux is 3. But there is one twist. The sign of electric flux is phi. Symbol of electric flux is phi E. So one thing, what is electric flux? It is but of electric field lines passing through the surface, normally. It's a very important thing. Normally is an important thing. How it is important? Let's see. Let's suppose this is your surface. The area vector will be like this. Yes, sir, because it's perpendicular. And if your field lines are going like this, let's suppose it's going like this, then how much will be the flux? The flux says the number of field lines passing through the surface normally is only known as electric flux. But sir, these field lines are not passing normally to this flux. Exactly. That's what I'm telling you. It may be making some angle theta to the area vector. Yes, sir. If it is making some area vector and electric field lines are the vector quantities, then I can say the electric field lines which is passing through this area vector must be the base component of this electric field will be E cos theta. Then I can understand one thing, that the electric field lines which are passing through this area are E cos theta, are making some angle theta, and its base component, and E cos theta is passing normally through this area vector. So I can write one thing. So the electric flux must be E A cos theta. This is the area vector. This is the area. Cos theta is the E cos theta is the component which is passing through this area vector. Exactly. I can write it this also. E dot A. E dot A means what? E A cos theta. Dot product. I can write it this like this also. Yes, sir. Exactly, you can write it. What does this mean, sir? It shows that whatever the surface is, like if your surface is like this and electric field lines are passing through this surface like this, so the normal vector will be kind of this, and there must be some angle in this field lines and the area vector. Yes, sir, exactly. There must be some area, like we can consider it. If the area vector is perpendicular to the surface, able to see it. Hey, electric field lines are passing like this, let's suppose. Then there must be some angle. It is not passing normally to the surface, and we are known that the electric flux is the number of field lines passing through the surface normally. We have to take the normal component of the electric field, and it is E cos theta. Then electric flux will be E cos theta into A. Which shows E dot A, which means E dot A. Yes, sir. And it's an scalar quantity. The dot product also is a scalar quantity. Yes. This is known as your electric flux. That's it. So we are ending this class now. The electric flux is clear. Area vector is clear. Electric flux is clear. Your charging and discharging of atom is clear. The trajectory of motion of charged particle in uniform electric field is clear. I hope everything is clear. Thank you so much for the class, and we will meet you soon.